Hi, my name's Thomas, and I'm an applications engineer here at Maxim Integrated. Today, I'm going to show you how you can add wireless data transfer to any sensor project using just an RF transmitter and an RF receiver. Adding a wireless data transmission component can improve your project's overall functionality because it allows you to have multiple sensors spread across a larger area that all send information to one receiver. Then the data can be processed, viewed, or stored for later use. For this project, I'm going to be using the MAX 1472 RF transmitter and the MAX 1473 RF receiver. These make a great pairing because they both operate at the same transmission frequency, they have an extremely straightforward setup process, they have shutdown functionality, which can drastically lower power consumption when turned off, and they can add up to 100 yards of wireless communication range to any project. For the brains of the project, I decided on the MAX 32630 Featherboard. This microcontroller has a ton of great features, but I want to focus on the deep sleep capabilities. This feature allows the microcontroller to power down into a low energy state and be woken up by an internal real-time clock signal or an external interrupt. The feature is going to be extremely helpful when we're not processing, sending, or receiving any data. Now, as far as the data that we're going to be sending, I'm going to be using the MAX 3208 human body temperature sensor. This temperature sensor offers extremely low power consumption and extremely high accuracy across a large temperature range. The temperature sensor is just one example though, because you can send a lot of different types of data via the RF transmission. Now that we have all the hardware picked out, it's time to start working on the actual data transmission. For that, I designed this very simple data packet below. It's going to allow us to send consecutive messages, it'll allow us to have multiple transmitters and different types of sensors attached to them, and it's also going to give us a variable data range for those different sensors. Now this packet is going to be extremely helpful because it's going to let us pick and choose how many transmitters we have, as well as choosing which types of sensors that we're going to add onto it as well. And now that we have all the hardware and software ready, I think it's time to start putting everything together. Alright, now we got everything wired up, so let's see how it works. These micros are ready to go. You can see there's no electrical connection between the two, so all the data being transferred is through the RF communication, and we have the little terminal window here on the right side of the screen to display the temperatures, and as you can see, every time I press this button, there's going to be a new temperature populating that screen. It also displays the device type as well as the transmitter ID. If we had multiple transmitters in different locations, we would know which location this came from, and we would know which sensor is sending the data. Alright, so now that we have the main functionality working, we need to start making the system more efficient. One of the big advantages of using RF communication pairs is the fact that we can have battery-operated sensors in very remote locations. So we need to make sure we can prolong the life of those batteries as much as possible. So let's go back, edit the code a little bit, and see if we can add some more power savings. And with just a few extra lines of code, we have a much more efficient system ready to go. Now, the functionality is not going to change one bit. You're still going to see temperatures being displayed out of the terminal at about the same rate. What you are going to notice though is that the onboard LED is going to start blinking. You'll see the LEDs lighting up when it's in the active mode, and it's going to turn off when it's in the deep sleep mode. The transmitter is set to send 1 second worth of information every 5 seconds. The receiver, on the other hand, is going to be checking for incoming data every half second for about 5 milliseconds. So it's going to do an extremely fast check, and if there's data, it'll stay on a little bit longer to make sure that it records it. But for a majority of the time, it's just going to return right back to that deep sleep mode for another half second. As you can see in the digital output, the receiver turns on for a very short period of time. If there's data there, it stays on for a little bit longer as it records it. Otherwise, it goes directly back to sleep. On the sender side, you can see that the period between turning on and turning off is a little bit longer. However, it turns on for a longer period of time as well. In one transmission, the receiver is going to turn on once during the transmission process. It will read that information and then return back to its low power mode. Before using these power saving techniques, a lithium-ion battery would run the transmitter circuit for about 3 days. That same battery used on the same circuitry but implementing these low power functions would last about 8 years. If you want a more detailed project write-up, check out this project's Hackster.io page at the link below. It gives a much more in-depth look at the software, schematics, power calculations, possible applications, and future work for this project. That's all from me. Thanks for checking out my project. I hope you enjoyed this video, and I hope you learned something new.